So kind of as a recap of what's going on, what this project is. Uh, this was the you can tell from the folder name. This is a video processing tool. It is Glowing Telegram is just the name that the random repo name that Geb gave us. That was like, okay, that is not unacceptable. And this tool is for managing stream recordings. So essentially, like right now, I'm streaming this. I'm also recording it locally. And what I do after these streaming sessions is I take the video and I upload it to YouTube and I do a little bit of editing. I would like to do more. I would like to do some interesting things with video editing, but some of the stuff is a bit repetitive and I want to automate that. And I just thought that would be a cool project, right? So the features here kind of listed and are in the README on the project on GitHub. And so there's kind of two angles on this. One is this is something that I think might be useful to me, and so it's worth some time to invest kind of building it. But also, I have not really had a lot of opportunities to do any Rust development in quite a while. And so this is kind of an excuse to spend some more time working with Rust and building some microservices for this architecture as outlined here for this application. So that's a bit of a recap. You can see I just added another item here for the features, which I thought I had wrote down at some point, but I think when I made the README I didn't include. So I have a couple of NVMe drives that I use for storing videos and editing them, but it is still a finite amount of space. And in the past, I've just deleted local recordings after a while, but I think I want to automate something as part of this tool that will archive them to maybe S3 Glacier or something that will be really low cost to store video files in the long term that could be, eventually retrieved if desired, rather than what I've done in the past when I have needed a recording. But there was a time when I wasn't recording locally and I would download the file from Twitch, but it's not as at least I think it was not as high quality as the local recordings that I'm doing now are. So it's another feature I want to incorporate into this. So that is the recap of the project so far from kind of a high level perspective. Now, a thing that has happened since the last stream is I noticed there were some problems with a bit of a port conflict. So I use Vite for my stream screens. Like when I have the countdown screen and the BRB screen on Twitch, I use Vite to provide those views and then load that as a browser thing in OBS. Anyway, so the default configuration for Vite has it just looking for any old port. And so this change obviously changed some formatting, but it also made it so that it will use port 3000 and only use port 3000 for the Vite config that's in our front end for the app. And so this will ensure that it listens on port 3000, and then in the Docker Compose I updated it to map to 8000 to 3000, right? So I can go to localhost 8000 to a port that won't conflict with our API port. Okay. And so that way we won't have a port conflict with the Vite client that I'm running for OBS. So anyway, so that's kind of what's changed since then. So I'm going to go ahead and commit these things, and we'll have a kind of a clean place to start. And for now, I'm just pushing this directly to main. I'm the only one working on the project. I don't even have any kind of build, like any kind of linting or unit test running or anything like that in GitHub, because it's early days, and this is just kind of the figuring out things phase of the project. Update README. Oh, right. So I said before, so when you have GitHub Copilot, there's a bunch of places where there are features. I thought there was one here. Never mind. But so here, there's little sparkles. It says generate commit message, and so this will use Copilot to generate a commit message. I don't know. I have mixed feelings about it. Obviously, it is arriving at something that is somewhat describing what the change is. Add to README. Otherwise, the commit message is like, oh, we're adding that capability to the project. No, we're just adding it to the README. Okay, so anyway, where do we go from here? Well, I already closed that, but I did start the project up again. I used the Docker Compose up command from VS Code, and I should have a terminal here, and I guess it's 8,000. There we go. So we have our React admin UI again. I think I'll split screen this so that we can see a couple things here. And I think where we left off was working on the CRUD API that is essentially providing data for the front end, right? So right now, if we click into any of these other areas, it's just the same data, right? We have streams, and this is the one part of the admin that is customized, is have specific columns, and the rest are using the guesser to guess what columns are there. So it's just looking at the data that's coming back, and the data that's coming back is always the same regardless of what kind of record it's requesting. So we can fix that somehow. So let's look at this main.rs. I guess I'll go full screen so we can see the whole thing. So here is, I have that common API lib base app that was based on the code that we did a few streams ago to provide all of the setup for Axum and tracing and those sorts of things. And so now we have this CRUD API main function that gets run inside of a container, and it uses Common API Lib to get a hook onto the app, and then we can add routes, and so then we have all these different handlers. And so, for instance, if we look at get list, here in get list, we are just hard coding a response. Now, I think probably a good next step. Let's take a step back as the next step. Obviously, let's talk about what the goal is, kind of in relation to CRUD API and the React admin, right? So the goal here is to be able to look at the different kinds of database records there are and be able to like click into them and look at them and edit them, and to be able to have actions that are performable on these items. So for instance, if I have a stream here, the stream, I want to be able to extract the audio and transcribe. No, I'm getting ahead of myself. So the stream, I want to be able to identify where either interesting areas are happening in the stream, or where there are silences or like a break. to be able to facilitate automatically generating episodes. And then on the episodes, I want to be able to generate transcripts. So I want to be able to select the episode and then select an action, perhaps like a bulk action for multiple episodes, and say generate transcripts. And that action is triggered in the UI. And then I want to be able to look at these transcriptions and be able to select one or more and say generate a summary, generate a description. And at some point, we're going to bring back in the little chatbot component that we worked on a few streams ago to incorporate that into this UI so that we can interactively refine the summary or description or the transcript using a ChatGPT style interactive prompt style interface using OpenAI's GPT-4 LLM. So that's kind of where we're going with this. So that's another level of kind of a summary of what's going on. But to do all of that, first we need to have the UI actually show the data that is in our database. And there is a database, or there was a database from the Django project. And I think what I want to do is I want to get into taking this handler, this get list handler, and what this handler is supposed to do is it's supposed to query our Postgres database. It's supposed to get the list of some kind of record and return that list of records, right? Now, how are we going to do that? So the handler doesn't know, like this handler is supposed to handle a request for getting a list of any kind of record. We don't know what kind of record. And so let's take a look here. So we do have a key parameter, and I assume there's some way to receive that in the handler so we know what this key is, and in the case of like get one or update or delete, what the ID is. So that should probably be the first step. So if we look at Axum's docs, probably search Axum Rust. Create documentation. Let's see, is there an example here? There's an example directory, maybe. Is there something about routes? Routes and handlers close together. Okay, so here's a... Oh, interesting. So here you have a function that returns a router from and includes inside of it in it a handler. Oh, hey Furiago. You think that's you find this interesting? I'm glad. I am trying to understand how to do something here. This music is very quiet. Let's turn that up a little bit. So this is interesting, having kind of these embedded handlers inside of the outer function. But this doesn't tell me what I want to know, which is how to get this parameter key or ID, it's part of the route, inside of the handler so that the handler knows what kind of record we're dealing with. Okay, let's go back here and maybe look at the crate documentation. Here we go. Handlers. There might be an example here. Let's widen this a little bit. There we go. So an extractor is a type that implements from request or from request parts. Query gives you the query parameters and serializes them. Path gives you the path parameters and serializes them. So path parameters, I think, are referring to these, like key and ID. Okay, so I think something like this. Does that mean we can do path, and then we have key? Okay, it's running cargo check. Yeah, that's not imported. We need to have Axum extract. Does that compile? That does compile. All right, so now we have this key, which should tell us the kind of record we're dealing with. So in other words, if we are, let's go back to here. Let's go back to streams and look at the network tab, and then unselect. Oops. Unselect and refresh. And you can see here we are making this get query to streams. So we're making localhost colon 3000 records streams. So streams here is the value that would be in key. And what we need to do is we need to then translate this name into whatever the name of the database table is going to be. What you wouldn't want to do is simply take this value and make a... Oh, I knew what you meant. Yeah, I see that you had a typo. But yeah, I know what you mean. Interesting, not intersetting. We can't just, like, you could string interpolate the key into a SQL query, but you wouldn't want to do that. You wouldn't want to say provide an endpoint that could retrieve any arbitrary table in your database. So I'll have to think about how we want to do that exactly, but kind of, so that's a thing that needs to be figured out. What else do I need to figure out here? So we don't have, like, let me pull up Docker. So we have a database container. It's running Postgres. Let's take a look here. In main.rs, we have this common API lib db create poll. And I think in our Docker compose file for the CRUD API, we are providing a database URL. And so we're saying, here is the database. Oh, hey, Brainless. Oh, the prefix, Furiago. It is some dummy data. You know, this is just something to return to show on the UI. But the purpose of the prefix is when I record videos locally for the streams, I have this folder. Let's see if I can do this in a way that doesn't show extra things I don't want to show on stream. There we go. So when I'm streaming, OBS saves video clips, like 20-minute long video clips of the stream, right? And so, but every file has a prefix of the date that the stream happened on, like when the video was recorded. And so what I was thinking here was that to make it easy for this system that I'm building to find all the videos for the stream, I would define the stream and give it a prefix, and then would find all the corresponding videos and pull them in automatically. Yeah, no problem. All right. So, uh, what we need to do is set up the database. So let me pull up pgadmin, and we can look at the database as it is right now. At least the one we've told our CRUD API service to use, right? So here's pgadmin, and I should have a local Postgres database. And we have a video processing project database inside, and it has a public schema, and it has no tables. There are no tables in there. So I guess it's finally time to look at how to do some setup. Didn't I? Right. So for the thing that was originally the test API that got renamed to AI API, I have a SRC, I have a schema. Right, so here's a test table. Presumably, right. So this service has some initial stuff set up with Diesel to be able to talk to the database, but I gave it a different database to use, test API. As it stands right now, AI API doesn't really need a database anyway. I'm just leaving that stuff there as a reference. But I think what I want to do, and I said this during some stream, but what I want to do is we have these different microservices. A thing I don't want to do is I don't want to have a database that the different services use to communicate with each other through. I want to have, if there are different database tables that different services need, I need to figure out a way to make it so that those services use their own database tables, and we have defined interfaces for the services to talk to each other in so much as they need to talk to each other. I also want to, thinking about like the architecture of this, going back to how this is described in the README, is the microservices are written in whatever programming language they're written in, and there is a database, but the services don't really share state. There is metadata in the database, and there are actual video files on disk, and in that way the state is shared, but I don't want to have like hidden interfaces in the database for the services to communicate through, because I've seen where that goes, and it is not good. So where does that take us? So what we need in CRUD API, because I've decided that CRUD API not only represents kind of how we're interfacing with the database, but I'm going to put the definition of the tables for the streams and the episodes and the topics. I think I'll put those the definition of those tables in this app, in this service. Yeah. So how do we do that? I don't really remember. Let's take a look at what I did last time. So last time around, we have a models.rs, and we have a schema.rs. Now, I note here in schema.rs that this was generated automatically by the Diesel CLI, but models.rs is not. I think what we're supposed to do, and I could go look at the Diesel documentation, but I think what we're supposed to do is define this models.rs and then use the Diesel CLI to then create the what do you mean by key? use the diesel CLI to generate the schema and the migration and those things. Never mind. All right. And I think everything else is set up in CRUD API in that service. Right, so here we have some extra stuff, but we're just using this create pool to connect to the database. I have seen example projects that will run the schema migrations for the database in Diesel to apply any changes when the application loads. But in this case, I don't think I want to do that. I'm not sure what you're referring to. That's what I get for flipping around a bunch. All right, so let's take this as an example, this models.rs, and we'll create a new file in CRUD API called models.rs. And let's see here. Create schema test. Create schema test. Interesting. Okay, I need to look at documentation to see how this is really supposed to go. Diesel Rust. All right, getting started. Which I've been here before, but we're here again. And we are going to look at, so Diesel CLI, we, a couple of streams ago, made a Docker container wrapper for Diesel CLI. So that's still a thing that we can use. We'll figure out how to tell the CLI what database we want to talk to. I think we just need to, in this project, or do we have a top level env file? We don't, nor should we. All right, so we need a .env file, and this is going to have the same thing we have in the CRUD API's Docker Compose, where we set the database URL, except it's not going to be DB. We'll just do localhost. I think that will work. Anyway, okay, we can run diesel setup, and it'll create an empty migrations directory. And then we'll create, we can do diesel migration generate. And then we'll write the SQL. Okay, and then we write Rust. This part we already have written, and we can reuse. I see. Okay, so I have the order. I was a bit out of order. So yeah, let's leave this empty for the moment, and let's do this. Let's cd into CRUD API, and then find the Docker command for the diesel CLI. Is this what I want? Do I need the network? I don't know. Let's see. A mistake I made before when I ran this was not including RM. Is it dash dash RM? I guess I'm going to find out. And then diesel CLI, and then the command from the docs, which was setup. We'll see if this works. Okay, so not accessible on localhost. That's probably why we needed that network command. Okay, so let's try that again. Diesel. Yeah, so this is PowerShell, which is it's PowerShell. What more can be said about that? But it's it has some. So I have some customization here to make fancy, prompts and stuff. But it's yeah, it's a command prompt made by Microsoft. That's not the default one that comes with Windows, or maybe it is now, but it's not the one. The one going back to like the DOS days is like the CMD. Yeah. Like the DOS style prompt. So PowerShell is a bit more powerful, hence the name, but it is running inside of the terminal, inside of VS Code with these customizations. Sometimes it gets a little bit janky how it renders out the prompt and stuff. So I've just learned to live with it. So I'm just rebuilding this command to include this network option. And then I think I also need to have this env refer to the DB container. And maybe this will work. It'll allow it to find... Yeah, of course. So Docker run tells it to run a Docker image. -- network, video processing project default. That's kind of the network that these containers, like this project, is running inside of. -- rm tells it to remove the container that it's going to use, that it's going to build to run the image when it's done. -it makes it so that running the container is interactive, so it doesn't just run in the background. -v maps the current working directory or present working directory to /app in the container. Yeah, CRUD API. That is where we are. Diesel CLI is the name of the image. What I've tagged the image that contains the diesel command line interface. And then setup is the command to run. So it doesn't seem to do anything. But it did, because we have a migrations folder. Correct. IT is interactive and TTY. That is true. I usually use them together. What's a circumstance you wouldn't use them together? I and T. I don't know. So now we have an initial migration. And so it tells us some things here. It says, this file is automatically created by Diesel to set up helper functions. It's safe to edit any future changes, yada, yada, yada. So I think the intent, is that we then make a second migration. Let's check the docs here. Right, so we do Diesel setup, and then we're going to create we can do Diesel migration generate and then a thing. So we can do something like that. Migration create. Generate. Create streams. So we're gonna. I'm just gonna. I think it will be most effective to focus on just creating the table for the streams and just. I don't want to spend a bunch of time creating all the database tables right now. I would much rather create one and then go back to the CRUD API and then go to the front end and like get it all wired together. and see it all working rather than like invest a bunch of time in one thing. I think that'll be more fun. So I ran that command. As you can see, it created 2 files. Interactive with the input, for example, no terminal required is why you would use -i. Let's say the Docker image accepts an argument, or you pipe the output of something. So you cat a file, although you could use less than, yeah, anyway. But yeah, that makes sense. I don't know if I've ever piped anything into or out of. Oh, wow. Victor Amius, thank you so much for the follow. It's appreciated. And welcome to the stream. All right, so back on track. We get these 2 files, an up.sql and a down.sql. And this is very similar to other schema migration things where you have a way to go from your present state to a future state. And then you also, that is the up.sql. And then you have a way to migrate back down, to go from whatever state you end up in and be like, okay, well, actually, we want to unwind that and go back and just revert those changes, kind of like an undo, right? And while there are a lot of circumstances where that sounds scary, like if you add a table, and you have a bunch of data in it, well, if you migrate down, you lose the table and you lose all the data. That seems pretty scary. But there's a lot of other kinds of things you might change in the database in terms of like adding indexes or foreign key relations or this or that or the other thing. And honestly, the worrying about the data is something you need to be thinking about with like backups and stuff and other ways of like these kind of tools are just the beginning in terms of like administrating a database, right? So this is more of a while I have used schema migrations to like not just upgrade but also downgrade things in a production environment, they're much more day-to-day useful in like a development environment. Always place a guard on your migrations for the production environment. Yes. I mean, in multiple levels, right? Like you probably don't want to have things scripted to automatically do down migrations against your production DB, but you also want to limit like who can access it. Victor Amius says, "Hi, I'm a Python dev in a big company, and I need to know some Rust and JavaScript framework like React. Thank you for the stream." That's cool to hear. Thank you for the thanks. You're very welcome. I am excited that you are here. All right, so that's a lot of context, but we have to write the SQL. So we just need to like create table, something like this. So this is what GitHub Copilot suggests. How do I feel about this? You know what I could do? You know what would be more... I mean, that's all well and good, and that probably works. I also brainless. I love Python too, mostly. All right. So what we could do is we could just create a table, or we could look at creating a table in pgadmin. So we could have like a streams table. You miss PHP? No. I don't miss PHP. So, and this gives us kind of an interactive way of creating this. And then so we can have like an ID. And then, is there a UUID? There is. Primary key, not null. And then, do this. And if you do this, then you can Ah, this is what I get for coming up with an idea for doing something on the fly. I was oh, there. Okay. There we go. Brandless says, you hate PHP. Notice how I downcase the name of it because I see it that low. No. I mean, the funny thing is, at least for me, PHP is something that is... Like, the memories I have of it are from, like, PHP maybe, like, 3 or 4 from long ago, right? And I know there are people that like PHP. It's because they don't have the trauma of using it in the bad old days, right? So JavaScript is fun. But now with TypeScript, we also have types. Okay, so this whole exercise of defining this database table, it's not really mysterious. We know what the data looks like. We already have mocked up in a UI what the data looks like for the stream. So assuming we didn't have already like a prototype project that we're basing this off of, we have a mocked up UI, right? We have mock data. So we have a good sense of like, okay, we're going to have created at, we're going to have a description, we're going to have an ID, we're going to have a prefix, we're going to have some like URLs to where like the audio track is and where the thumbnail is. This is weird. Why is the title a date? That's wrong. I think I messed something up here. But anyway, so we have like 1, 2, 3, 4, 5, 6, 7, 8, 9 things. 2, 3, 4, 5, 6, 7, 8, 9 things. Can I make this bigger? I can. Ooh, actually maximize. There we go. So we're going to have a title, description. Brainless says, JSTS are not my favorite, but meh, web is web. I mean, it's just, JavaScript is so appealing because, it's something that can be both front end and back end. I'm currently doing some work, Brainless says, making changes to a gem in charge of all internal operations on a few of our services. Scared? No, you are. This is fine. I mean, what could possibly go wrong? I mean, so I assume this is Ruby because you said it's a gem. And that's what Ruby packages are called. If I understand correctly, yes. All internal operations on a few of our services. Not all of the services. I mean, as long as it's only a few. Okay, so title, description. We already have ID. We want a prefix. We want a speech audio URL. I'm going to call it that, and then a thumbnail URL. And we don't have to make the table's column names match what show up in the UI. Nothing can go wrong. It just handles all operations, including booking for a flight and package paths. Sure. So, I mean, that sounds like a thing that involves a company making money. People might be sensitive about that. I don't know. People seem to care about money. Okay, so title, description, prefix, URLs for the speech audio and the thumbnail, and we have 2 IDs. Okay, this UI is a little, it's not quite right. So I don't, yes. Okay, so created that and updated that. And so the data types for these, this would be like just varchar, character varying. And then this could be text for the description. This will be character varying. This will be, I don't suppose we have like a URL or, no. More varchars. And then this should be like a timestamp. Always with time zone. Maybe. Let's see. Brainless continues. And the secret no one knows is the company is no one knows, and the company is you don't know crap. Okay. Yeah, Axum is the I guess you could call it a web app framework. Yeah, that's what we're using here, which we might see again in a little bit once we get through this database stuff. So generally speaking, things should not be null. Except like created at should not be null. Thumbnail URL. I mean, like the URLs could be null to represent we just don't have a value for them, or we don't have a value for them yet, and that would make sense, as opposed to having an empty string. I think I'm going to say not null. And do we want links on these? What if I didn't? So many fancy options here. Anyway, so here's kind of an example, right, of that table. And I think this is not too dissimilar from what we saw that Copilot generated. But I was kind of hesitant to just like take Copilot. So this is what Copilot suggests. And this is what we made in pgadmin. So we have a UUID. The syntax is a little different. We're defining the primary key at the end here. I don't know if this would work. It might. And then name and description is what Copilot came up with, but I wanted to have title and description. Ultimately didn't matter. Created at, updated at, timestamp with time zone, and my version. I'm not going to include the schema here. So there we go. There is our up schema. Very belabored. This file should undo anything in up.SQL. So there we go. If drop table if exists streams, right? So this should get us where we're going. So the next step was to do diesel migration run. And cross our fingers. Okay, it ran. It did an error. So in pgadmin, notice we didn't save this. We didn't actually do this in pgadmin. Whoops. Close that. Changes will be lost. Yes, good. And if we look in here and refresh, we see our streams table was created. All right. So we have our streams table created via diesel. And that means now the biggest benefit in my mind, and like in the foreseeable future, right, is I want to run this in a different environment. Like I want to actually set up an actual permanent server for the service. I can create a new database that doesn't have any initial data in it, because any data I put in here might be like just fake testing data, and I can apply these migrations and I can create this database. And I have basically all of the instructions to recreate the database. No, as in, so this is a development environment in a sense. Right, so I have Docker running locally, I have VS Code and stuff, but if I set up a VM or a server somewhere else, and I want to actually host the all of the stuff somewhere else, I could theoretically make a backup of my local database, and I could upload it to there, and I could restore it, and I could do that. But then that's going to have a bunch of test data. It might have things like experimental things that I didn't clean up properly. The schemas will provide, like the up migrations will provide specific instructions on how to create the database from scratch. So, Brainless Society wonders, how can you avoid running these migrations in prod with your structure? Well, the up migrations I would be running in prod uh, to initially create prod. And then, thinking bigger scale on like a production project, part of doing a deploy would include steps for applying up migrations. And then there might be other work that needs to be done to ensure that that's done safely, thought put into like order of operations. You make code changes that depend on a database table being there. Well, you need to run the migration first, or there's some like considerations around interleaving. Sorry, I should explain myself better. Let's say, how would you avoid doing something like a revert on prod? Don't do that. I think there are some limitations, right? Because like you might have a dedicated user for doing these migration operations on your production database. And when you do that, yeah, you want to revert in lower environments, but you don't want to in prod. Probably not. And so let's say you've automated your deploys to production, right? So code gets checked in, it's reviewed, however many quality gates or other review processes you have, and then someone signs off on it, or automated system signs off on it, and it gets tagged and it gets auto deployed. And part of that deploy is that migrations are run. The way to prevent someone from running a revert is that's like the user that has permissions in prod to do like these schema changes, these schema operations are it's just like a system user, right? So only the automation can do this, and that process itself is code that's reviewed. You just don't have anyone doing it. Now, maybe presumably there's like administrative users that have broader rights that would be able to do things if necessary, but the automation that would be applying these migrations as part of a deploy, just you wouldn't have it run the down migrations. And then if it wasn't automated, then you'd have probably a need to have like procedures at a human level, policy, process, procedures for who does what, when, what permissions, reviewing commands, and those sorts of things, right? But all right, so now we have a schema.rs that was generated automatically by Diesel. So we have our table, and here's a representation with Diesel's macro of the table that we just created. And this looks right to me. So what's the next step according to the Diesel docs? It's a good idea to make sure the down.sql is correct. You can confirm it by redoing the migration. Interesting. So redo must do like a down and then an up. Let's try that. Redo. I'm not using a numerical ID. Any reasons? Concretely, like in this case, no. I could use, the just an ID that increments itself. I saw in the Copilot generation of the schema earlier that when we were doing the up migration, that it had a UUID, and I was like, that's interesting. I wonder how that would work. So follow-up, is the index created automatically by Diesel for the ID? So because I designated that as the primary key, there should be an index already. or not. I could just be wrong. Oh, right, the table doesn't exist because it got dropped and recreated. There we go. So you can see in, there's not an explicit index defined here. Let's check Postgres docs. PG index for primary key. Yes. So it says Postgres automatically creates a unique index when a unique constraint or primary key is defined for a table. So I think it's just not shown in the UI, but it does have a primary key. Yeah, this is the current doc, 16. Postgres automatically creates a unique index when a unique constraint or primary key is defined for a table. This index covers the columns that make up the primary key or a unique constraint and is the mechanism that enforces the constraint. Yeah. Thank you for your question. It's good to check, right? Here we go. It's listed as a constraint, which is fair, but yeah, typically relational databases should, should have some kind of index for the primary key. Now here's a question: if we insert, let's try test. Let's try query tool. Insert into streams values, and we have a bunch of required columns. Title, description, created at. I didn't. Oh, I could have had a default. Ooh, let's do that really quick. Can we do this? Let's redo the migration. Okay, that is accepted. So now we don't have to specify created at. It'll have a default. What else we got? Title, description, prefix, and then I think the other columns are nullable. So we'll leave them null, and we'll say test, test, test. Does that work? Okay, so we have to provide a UUID for the ID here. Is there Postgres UUID primary key? A sequence in Postgres does exactly the same thing as auto increment. So this is the sequence is the word I was trying to think of before, is the thing that I have used in the past, right? So we just have an integer value. Aha. Oh, this is old. Okay. Gen random UUID. Gen random UUID includes one function. This function returns a version 4 random UUID. Okay. So if we do this, and then redo the migration, and then we go over here to pgadmin and run this. Okay, speech audio URL. All right, those aren't nullable. I decided I was not going to make this nullable. I was going to make it so that you had to provide an empty string if you wanted them to be empty. There we go. So we just inserted into our table. So if we right click here and view edit data all rows, then, oh yeah, the table doesn't exist. Or this version of the table that we saw from before doesn't exist because it just got recreated. View all rows. There we go. So there's our random UUID primary key and the values that we put in, and we have created at. which apparently it's about 1730 in UTC. Could we do something for the updated app? No. I think we would need a trigger. We would need to create a trigger to populate updated app. Could we do that? Create trigger to update updated app column. Okay, interesting. DSL set updated at is interesting. We have a function. Maybe we could just use this. Yeah. Would that work? Let's find out. Okay, it applied. So if I were to go back to this query and I were to do update streams set title equals test2, there's only one row, so I'll update it. And then if we, can we refresh this? Table doesn't exist anymore. Of course, let's just select star from streams. Oh, right. Right, because I just dropped the table and recreated it. So that, of course, doesn't exist anymore. Okay, so now if we were to update the table, now we should have an updated at value. There we go. So it was created at 1732.27, and it was updated at 1732.34, just a few seconds after. So that all looks good. Success. Okay, so that was our database diversion. That was not really what I was planning on focusing on. Okay, and then so many windows. So the next step is to write some Rust. Of course, we've already done the connection pooling stuff. We do need to have this in our main.rs. We'll put those in there, models and schema. Of course, do we not have diesel as a dependency? Probably not. I'll fix that. Updated at is defined as nullable. Correct. So created at is not nullable, but updated at will initially be null until the record is first updated. I think that makes sense. That's what I've done every time I've had created at and updated at, or something along the same lines on a table. I guess you could have it where created and updated values are initialized when the record is created. Yeah, that's what you just said. I've always done it this way. Because then you have an extra piece of information, right? Because I guess it depends on the resolution of your timestamp. But theoretically, yeah, if it works, it works. But theoretically, you could have something where you create the record and then immediately update it. And then the timestamps would be very similar or potentially the same depending on your precision. But I don't think it matters. I've just always done it this way. It's tradition. Anyway, cargo toml. I want to grab diesel and diesel async and put those in this project. And that should make our file here happy again. And then in models.rs, we need to put something, I think. It doesn't auto-generate it for us, unfortunately. But we can start with this, and then what was our streams? There we go. Is it checked for backend? It is. Diesel PG. Okay. Now, this is what Copilot has generated for us. Let's compare this side by side with our, not our model, with our schema. Okay, so we have an ID that is a UUID, maybe. Right. So we have potentially some dependencies we need to pull in. And then title is a string, description is a string, prefix is a string, speech and thumbnail URLs are strings. We have created at. I don't know what a chrono naive date time is. And then an option for one. So let's do some Googling. Naive date time. It's an ISO 8601 combined date and time without time zone. Well, that's interesting. Because the column in the DB has a time zone. So why would this one be naive? Can we not be naive? Is this going to matter? You want a split keyboard, but those are so expensive. Most of them come assembled, and I have zero skills in that area. Well, they come unassembled. Oh yeah, you're talking about the ones that are like in multiple, like split in the sense they're like multiple separate keyboards, effectively, like one for right and one for left. I think I've seen some of those. I didn't know they come in parts. It's interesting. I've seen some stuff online about people doing custom keyboards, like, designing their own thing. That involves, a lot of work, probably beyond just assembly of components, but I think you can get them assembled, but it's even more money. I see. Well, I don't see anything other than, maybe I'm just looking in the wrong place. I don't see anything other than this naive date time, and I don't know. We'll see. Let's just go with it, and we'll see what happens. So let me go cargo.toml from AI API, because I know we have I thought we had chrono in here. Yep. And is there a UUID crate? Let's go to crates.io. Is that right? Looks like it. UUID? A library to generate and parse UUIDs. This looks promising. Updated 6 days ago. Yoink. Alright, so now it doesn't like that. Aww. Maybe diesel rust UUID. Feature UUID for diesel. Maybe we're missing that. Let's check our cargo toml. Diesel. Yeah, we don't have a UUID feature. And suddenly, this works. All right. So now, finally, we have the database stuff defined to be able to actually implement the query. Finally. So I think the first thing we could do is maybe just like, we're going to ignore the key and we're going to write a query to pull this data from the table, from the streams table. So get list of records from streams table using Diesel. It'd be great if Copilot could write it for us. What does it do? Model stream get list await unwrap. Is that a thing? Probably not. Great. Models. What did I call this? Oh, I did call it stream with a capital S. But there's no get list. What is there? I don't know. Okay, let's look at the docs some more. All right, so use self schema posts DSL star. Okay. So this is going to be interesting. How will we do this when we want to have different tables that are parameterized? How is that going to work? What publish equal to? Oh, actually, you may have a good point there. Well, I think, when we get to the episodes, database table, we may want to have a thing for tracking whether or not the episode has been published. It's been uploaded to YouTube. Let's put a pin in that. Is there a way in Diesel to dynamically select the table we want to? I don't know. Anyway, let's not worry about that quite yet. So schema stream DSL star. Okay, and then we want to state. Oh. Hey, Algo221. Thank you for the follow. Hope your Sunday's been going good. Assuming it's Sunday where you are. Appreciate the follow. Hope you're enjoying the stream. All right, so does this even compile? Hold on, we have an example of how to do this in the other projects. So I think in one of these, yeah. So state app state. Let's do side by side. Yeah, state app state. So I mean, you can you can count on GitHub Copilot to copy and paste code from your project, which is what we want. And then we also need to import. We need to use Axum extract state. Should just add that to where we were pulling in path before. So this is basically telling Axum when it's calling our handler to provide us or we're extracting, let's say, the state and the key from our handler, and then it doesn't like that. Could not find schema in self. Let's see. Use create schema. Can we do that? Could not find stream in schema, but it's right. Oh, it's right wherever we have it. Schema.rs in CRUD API. Oh, it's not. Is it models? I am confused. Also, it's this should probably be streams to match the... No, it isn't like that. It wants it to be uppercase like this. And that makes sense. I'm just concerned that the inconsistency here might be problematic. Okay, so let's see here. So let's see. If we do this, unused import. Yeah, because we're not using any of this stuff from DSL yet, but we will. And then AppState doesn't implement std-fmt debug. AppState cannot be formatted using the debug formatting. So this error is on purpose. So one of the things I noticed, fortunately not on stream, is that if you have AppState derive from debug, at least in the case of our AI API, one of the things that's in the AppState is our API key for OpenAI. And so when I had AppState in the AI API service, have it drive debug, it was logging the app state, including the API key, and I didn't want that. So what I did was in somewhere. Was it? No, it's not here. I thought I did something to tell it not to bother outputting. What did I do? Because I don't see here the thing that I did. Didn't I do something? Maybe... Maybe it ended up being in the common API lib. See, because you can see here, we read from the OpenAI key path. So we read that file and we dump that string into the app state for this particular service. And so you wouldn't want to have that logged out. But where did I put the code that is actually protecting us from that? That's interesting, because then I would think otherwise. Like, I remember specifically something in the route or the handler setup that was excluding a piece of state from app state. But I don't see where that is anymore. It's interesting, right? Because we're not getting this error. We're also not instrumenting this. Maybe that's why that error went away here. Okay, so I think I perhaps lost that bit of fix from here, but it doesn't matter in this case because we don't have a secret in the app state. So what I'm going to do for this app, for CRUD API, is I'm going to go into state.rs and I am going to derive debug. Yeah, I don't care about that. But that will make it so the instrument won't complain. I think that's it, is that in the past, the method that I was testing, I put instrument on, and it, oh, right. That was probably when I was testing the open telemetry tracing and a bunch of other stuff and trying to figure out how to make that all work. And then I ditched most of that because it wasn't working the way I wanted. So that fix must have been lost with that. Whoopsie. Okay, so can we read from a database table? Okay, so let's look at the diesel docs. So we're supposed to be grabbing the connection. So we should get that from the state. State dot. For some reason we don't have autocomplete, but it should be in state. It should be like state.pool or something. Let's look at our state.rs here. So yeah, we have a pool method that grabs the pool from the state. So we have like state.pool. That's fun. Let's do this. Let's say let connection. Does that compile? It does. Copilot got it right, maybe. And then let results equals streams.filter.load. Is it? Yeah, it is. There's a filter thing. We're not going to do that quite yet, but we do need to implement filtering to make this compatible with React Admin. And then we also need to like limit. We need to select, load, expect. So all that stuff seems right. We don't need to filter, but we're going to limit maybe 10. And select. Now, does this work? I have a feeling that this... Okay. Oh, yeah, topic IDs. We need to figure that out. What is this complaining about? Following trains are implemented down in scope. How to use method not found in table. Limits for start table and current scope. Method not found in table. So we are probably missing a thing. Yep. Okay. Cool. And so these things don't exist. What does exist? So if we look at our schema, what's this complaining about? Cannot find speech audio track in scope. Speech audio URL. Models. Speech audio what? I'm confused. Similarly named unit struct speech audio URL defined here. Cannot find value. View problem. Well, it's not a problem here, is it? It's there. Thumbnail URL. Excellent. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 things there, and it's not complaining about any of them, so we must have all of the right things. And then, of course, this is streams. Okay, now it's stream from... I'm confused. What is this type supposed to be? We shouldn't need to specify that, I think. And then this needs to be mutable, which it shows in the docs. It says let connection equals mutable reference, yada yada. So that's... And then we don't need that there. Trait bound, BB8 API pull connection, load connection is not satisfied. Load connection is not implemented. Great. What does establish connection do again in this version? Right, so this doesn't use the connection pooling that we're doing. This is just using PG connection from Diesel to establish it. I don't know why I'm not getting like hover over. At one point, I was able to hover over things and see what their types were, but that doesn't seem to be working right now. Let's maybe start Rust Analyzer. Is that what's gone wrong? Doesn't seem to be doing anything though. Aww. Okay, state.pool.get. Await unwrap. Can we... Let's do a little digging here. So in in common API lib db.rs. So this is where we're creating the pool, right? So we're using this bb8 crate, its pool. We're doing a builder. We're doing things. We unweight and unwrap, and so that gets us a pool, and so that's a bb8 pool. And now I can click on that. Okay, so pub crate inner m manage connection, a generic connection pool. You have a builder, a state, a get. So get should return a connection from the pool, and so this is a result of a pooled connection. And this has some methods. Deref mute, fmt drop. Okay, that's so like get await unwrap is interesting. Is there like a con that we can read out of that? Nope. Field con of struct diesel async pg connection is private. Well, now we know the type that we have there. Let's see what Copilot suggests. Into inner is interesting. Let's see what that does. Does that even compile? There's no get mute. It should just be get. Yeah, that doesn't work. Okay. But you can't tell me what will work. So load. Explain this, Copilot. Oh, that's a tag I forgot to put on the stream today that I normally do for these coding streams. GitHub Copilot. There we go. It seems to think that there's a load async method. I don't believe that's true. Let's try it. There is no method load async. Just it hallucinating things. Is any part of this explanation true? So BB8 API pulled connection type does not implement the load connection trait. That is, I think, true. So we can see the trait load connection is not implemented for BB8 API pulled connection. So let's try Googling. Load connection traits. Hey, there is a result. This looks familiar. Pool.get.await.unwrap. Connection is not implemented for pulled connection. This is a user error. This example imports diesel run query DSL instead of the async counterpoint. Ah. So I think I have a sense of maybe what's going on here. If we... Okay, that's not a thing. Worth a shot. I think there are things here maybe that... maybe in... What about this? Nope, not there. Yeah. In models? Nope. So we are using diesel async. No, this uses diesel table. Diesel async PG async connection is interesting. Is there someplace else? Maybe it is this. Maybe this should be this. No. Alright, well, I'm going to keep on trying things until something works. What are we doing wrong here? Obviously, this is going to fail until the handler is not broken. Is there something else we need to import? So here is let mute con pool.get.await.unwrap diesel delete person table execute await unwrap. I mean, I guess I can try adding these additional uses here. Well, that does something. No method name expect for struct and then in current scope. Okay. Type inside async block must be known in the context. Cannot infer type for type parameter u. So this is interesting. Okay. Cannot infer type of the type parameter u declared on the method load. Huh. Maybe I should read the docs for diesel async. Yeah. Okay, those things don't get used anyway. Do we need to do anything for our struct? Looks like no. Okay, we have async PG connection establish. We have a connection. And select load mute connection await. What if we borrow that for a second. Nope, you're not happy about that. Can it type inside async block must be known in this context. Label cannot infer type for type parameter u. Huh. Does that make you happier? Nope. All right, so here's an example using BB8, which is the thing we're using for connection pooling. We have a pool. Let mute con pool.get.await question mark. The trait from residual, blah, 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 is not implemented for thing. Cannot use question operator in an async block that returns Right. For this to work, we would need to return something else. Hence why we haven't unwrapped there, I think. Let mute con res users table select load. Huh. Yeah. Still don't like it. Field expressions cannot have generic arguments. The double colon here is kind of weird. What if we look at the raw README? So BB8. Oh no, it's intended to be like that. That's kind of weird. Now, did we provide the features? Here's the thing that has bitten me over and over and over and over again, is providing the right features. Okay, Postgres and BB8 to the crates that we're using. That's really important. Okay, so field expressions cannot have generic arguments. Oh yeah, first of all, this is called connection.con. And you're unhappy. Why are you unhappy with me? Attempted to take value of method load on type, all of that. Method, not a field. Field expressions cannot have generic arguments. I don't know what that means. My Rust is not strong enough to know what that means. I wonder... Is there... Okay, none of that changes that. Okay. I wish I had a clue. Okay, well, we are slightly over halfway into the stream today, so I'm gonna take a little break here to think a little bit about this and get some water, take a walk around the house. I'll be back in just a few minutes, and we'll continue with some more figuring it all out. I'll be right back.